everybody, to another episode of this Puget Systems podcast. We're joined today by Puget Systems' own Chris Stevenson, our expert in server and storage systems.
Yeah, business development manager for our servers and storage product lines. Yeah,
perfect, right on. And that's what we're going to be talking about today. And so not just like hardware specs and things like that, but use cases, customization, kind of just run through kind of a quick overview of all of it, really. I'd like to start just what are servers, I suppose, and how are they different from, like, say, a high-end desktop or like a network attached storage solution?
Yeah. Servers are basically, computing products built for data center 24/7 environments. So it takes the requirements that we have to run the world's infrastructure, not sitting at your desk, put it in a big room with power and cooling, and essentially, run the day-to-day things that we interface with but don't see every day. Websites, cellular telecommunications, medical research, all that kind of stuff is usually happening within the walls of a data center.
And so why would someone, say like a potential customer, invest in having their own servers instead of just going like with, say, a cloud solution?
It really depends on the workflow. The thing about cloud is it's very easy to deploy, especially for startups. Mm-hmm. The problem is that as your needs and resources grow into the cloud can become very cost prohibitive. Sure. To an alarming degree. I've seen a lot of customers that have moved strictly to the cloud and then come clamoring for, okay, how do I come back on-prem now that I've gone to cloud, just due to the cost alone. A lot of the deployments are a lot easier to do. You don't have to manage your own hardware, your own infrastructure, your own network. But the costs are usually the biggest factor we see when somebody wants to move out of the cloud and come back on-prem. And kind of repatriate their systems back in-house. So that's typically the biggest thing we see with cloud, especially when it comes with anything with high-end computing, storage costs. It's really cheap to get your data into the cloud. It's very expensive to get your data back out of the cloud. So anytime there's that data moving is where we typically see a lot of costs. That and anything computational, AI, high-end databases, that's where you start to see really high costs in the cloud.
Yeah. It kind of occurred to me. It's almost like buying a car versus leasing it, almost.
A little bit, except with the cloud, I feel like the leasing cost is astronomical compared to the purchase cost.
Sure. Yeah. So I think there's some common misconceptions when it comes to servers. Like buddies of mine have game servers and things like that, but oftentimes when people talk about servers, we think like the term heavy iron comes up. Mm-hmm. And how do you address those sorts of I don't want to say misconceptions necessarily, but those concerns, I suppose, where maybe somebody who has like a smaller studio might not think that a server or a rack-mounted solution is appropriate?
I've heard that term too. Big iron, heavy iron. It's not too far off. I mean, the enterprise data center systems are big, they're heavy, they're loud, but they serve a purpose. If for customers that are wanting to centralize or have better control over their equipment, moving to dedicated servers is potentially a really good move, especially if they have the ability to do anything in the realm of virtualization. We're seeing a lot more customers that are, even with workstation products, since the pandemic, they are virtualizing their work, their staff, they're virtualizing their resources. And so we'll see a lot more customers that are doing virtual desktops for their employees, and centralizing those all in one location. So I think it really depends on the customer's workflow and what their use case is. But especially with the advancements we're seeing in AI, even internally here at Puget, we're looking at the power requirements of a dual RTX 5090 based system. Pushing the limits of what a standard 120 volt US power socket can do, which is pushing us into data center level power for the machines that we used to just be able to run at our desks. So I think it's a natural progression that depending on the needs of a customer, you're going to see them push into the server space no matter what. And then it's just how they want to accomplish that. And like I was saying, virtualization is a really great way to do that. and you can consolidate and put a lot of hardware in a box, put it in a data center, and let it sit over there and do your workflow remotely, and still have a lot of the same benefits as having all that power sitting at a desk.
Actually, that brings up kind of a good point. We're most Puget Systems is mostly known for workstations. At the few of the shows that I've been to this year, even people have been surprised that we're showing off sort of these rack-mounted solutions and stuff. So I guess should just kind of give a quick touch point on what do we offer in that space.
Yeah, over the last couple of years, Puget's been expanding the portfolio, and the term I like to use is now we offer everything from the desktop to the data center.
Ooh, I
Um,
like that.
it sounds pretty fun. We offer everything from mobile computing products now, mobile workstation products, all the way up to high-end AI training and inference type systems, up to the big NVIDIA GB200 type configurations if a customer requires it. And the reason for that expansion is just we're seeing that fundamental shift with so many of our customers, where their demands are pushing the limits of what they can do in a desktop product.
Mm-hmm.
But they're looking for that same guidance that they get on the workstation side. They're looking for getting that from Puget, and so that's one of the big reasons we're pushing into that space. It's just kind of a natural progression for us and what the customers are kind of asking for, to expand into that space. So yeah, we offer products basically all the way through the stack, from the mobile to the workstation, all the way up to those rack mount servers and everything in between.
Yeah, that's cool. And I guess on a similar sort of route, we do offer some pretty flexible customization options, although within a fairly narrow framework. Like you can't just pick any brand of graphics card that is out there. And servers, I think, from my perspective, I guess, would be even more tightly controlled. How much flexibility is there when it comes to like server configurations?
Well, it really depends. So we have kind of two distinct product lines that we offer. One is what we consider our true enterprise class servers.
Mm-hmm.
Those are going to be a little bit more restrictive on capabilities, just because of the form factors we're playing with here, and the power and the cooling we're talking about. Typically, in our 2U rack mounts up to 4U rack mounts, you're going to be looking at some of the professional GPUs,
Mm-hmm.
like the new NVIDIA, hopefully I get this right, RTX 6000 Blackwell Server Edition, I think is the official title of that product. Those cards, and then the NVIDIA H200, those require very specific power requirements, very specific cooling requirements, just because of the amount of horsepower that those products are carrying now. So there is some restrictions when it comes to that, just because of the thermal loads that we're dealing with,
Sure.
for some of these products, especially around anything GPU enabled with AI. The other product stack that we kind of offer, it's kind of a power user mix, where it's not quite a server and it's not quite a workstation. It's kind of a mix in between. And we're seeing a lot of popularity on those rack station products because of the fact that they are a little bit more flexible,
Mm-hmm.
and they're going to be geared towards some of the main workflows we see, like on-site media creation, virtual production, LED volume type customers,
Okay.
where they need that additional horsepower. They need additional features like synchronization, or we're seeing a lot more in the SMPTE 2110, utilizing NVIDIA Bluefield, and those have different requirements that aren't quite fit for a full-fledged server product, but they're
Okay.
definitely not fit for a workstation product either. So there's a lot of those workflows that we're focusing on building those products around, and coming up with some customized solutions specifically for those workflows. We're seeing a lot more AI at the edge,
Oh,
in
okay.
retail and medical, where there's AI processing being done at the physical location versus sending all that data back to a data center. And so we're working on developing some products for customers around those types of scenarios as well. So I think it really depends on what that workflow looks like, and how our customers are pushing that into that next phase, that requires hardware that a desktop workstation just can't do.
Yeah, right on. That's cool. I like the AI on the edge sort of thing. It's I feel like it's a fairly newer term, or at least I've only just recently been hearing that term, and I think you kind of defined it really well about how they're doing that processing more locally, I suppose.
Yeah, they're doing a lot more, where the data is being acquired. Retail is doing a lot with like computer vision, right?
Mm-hmm.
So they're using AI to look at, for example, let's say you go to a sports stadium, and they have camera systems throughout the whole stadium for security, right? And they can
Yeah.
see where everyone is, and they can do facial recognition and all that kind of stuff with AI. But then they could take it to another level where they can see where the bottlenecks in their stadium are. Where do they need to improve security? Where do they need to improve the flow of people? Can they use that data to say, everyone is going to concession stand A. We want to tell them through reader boards throughout the stadium, hey, there's long lines at concession A, go to concession B, and they can do that all automatically with AI. So there's a lot of use cases for stuff like that. We've got some other customers that are doing products around, um, uh, the retail side of, trying to think of what to call it, uh, product placement within
Oh,
a store.
okay. Hmm.
They can use AI to see, how many times is a customer going up to a specific shelf and looking at a specific product versus another product. And a lot of that can be done at the edge without having to send all that data back to a central location, because it's very focused type AI workflows that we don't need as much power for. But yeah, there's a lot of really fun ways to use AI at the edge.
Neat. Yeah, that's man. Some of the we'll have to talk a little more, maybe deep dive into some of those use cases a little bit because that seems really interesting. Way more, way I don't know, just a broader reach than I would have anticipated. Especially on the local side, like it makes sense that like if you're doing a bunch of street cameras and stuff, and you're doing like traffic analysis or something, you want to send that someplace else where you might have a lot more of the powerful hardware. But hearing that like your local Safeway might have a little server in the back room, making sure that customer flow is set up well or that sort of a thing. That's really interesting.
Yeah, Houston, they definitely see how many times you go and look at the Count Chocula cereal every day.
I'm more of a Boo Berry kind of guy, honestly. To be honest with you, uh, so we recently announced a new 5 node 6U rack station. I guess what exactly is that, and what inspired us to sort of develop this product?
Yeah, for sure. So our new 6U5 node rack station product, it allows us to get better density from some of our rack station products. Most of our current rack station products are a 4U form factor, which is great. We can fit multiple GPUs in there, high-end CPUs, and a lot of horsepower. However, we're seeing a lot more customers, like we were talking about earlier, since the pandemic. They're moving a lot of their employees virtual and offsite, but
Mm-hmm.
they still want to control their data and have security around that. And by doing remote virtualized workstations, that's a way that they can do that. But with that form factor, as you start to expand into multiple employees or large numbers of employees, you're going to start running into space constraints. So that our 6U5 node, it's a great rack station product for customers that don't want to do full virtualization on their workstations for their employees, and they still want to do bare metal, but they still want to get some of that desktop level performance in a much tighter form factor.
Okay.
So if you think about it, if we had to do a standard 4U rack mount, we're going to occupy 20 rack units of space for roughly the same that we could do with our 6U5 node in 6U of space, right? Because
Oh,
we have
sure.
5 systems versus 5 4U rack mount systems. So it's all about the density. We're seeing a lot of interest in that from like the game development community because they're wanting to run test beds for new game development with different GPUs, different CPUs, and they can do that in our 6U5 node in a much denser space. And each node is independent. Utilizes its own redundant power, its own network, its own connections. So it's a really good solution for anyone that needs that workstation horsepower, but in a dense rack mount form factor.
So we're basically cramming 4 regular sort of desktop or tower sort of systems into, or I'm sorry, yeah, five
Five.
desktop systems into. I guess would be about yay thick.
It's about it's
Six,
about 6 U space. Yeah,
wow, that's pretty
yeah,
cool.
really, really, really dense.
And I guess since it specifically says 5 nodes, those would be kind of individually, almost like Intel did a Blade. I think it was Intel did a Blade servers back in the day. Do they still? I
It's a
don't know if they still
similar,
do that.
yeah, it's a similar style design, but each node is independent. And in a traditional blade system, you have a shared backplane, a shared power infrastructure,
Mm,
shared connectivity. These are all independent nodes. They're just as dense as we can get in that form factor.
Neat.
So you could literally pull a node out, set it on a desk for development. Somebody that needs it somewhere else, it could be pulled right out and moved along, and it won't affect any of the other units because they're all independent.
Oh,
So we're also seeing a lot of customers utilizing that for some LED wall type
oh,
workflows as well. We're able to actually do professional GPUs in those with Quadro sync kits. So we can actually do synchronization across
okay.
nodes for LED walls, which is another big get for that because of the density that they can get. So we have some customers that are doing that. Um, and then I think there's some other customers, there are other scientific workflows where they don't need a ton of horsepower, but there's a lot of different potential use cases for that type of form factor.
That's neat. Yeah, imagine, especially the virtual production thing. That I imagine you could power a fairly large volume that way, in something fairly portable.
Yeah,
Wow,
yeah,
wow, that's pretty cool. So, I guess when it comes to support, can you talk about a little bit about that? Since they are, you said before, they are kind of individual nodes. Is it sort of like a hot swap sort of situation? How does that work for on the customer side and our side?
yeah. So since they're independent nodes, what makes it really easy is that you can pull out just a single node out of that configuration and send it in for service, or if it needs to have its operating system reinstalled by your IT team, it doesn't have to take down the other four nodes in the system. They are fully independent, so you can just slide that one out, send it back to us for repair if something happens. Have your IT team refresh it or do any hardware upgrades. It's all independent, so it's not going to affect the rest of the systems in that chassis.
All right, that's pretty cool. That makes a lot of sense though too. Like, so we've kind of, in terms of the 5 node, the 6U product, we touched on some of the different use cases for that particular product, but I kind of want to expand a little bit on that in terms of our offerings in rack mounted solutions, and kind of dive into some of those questions as well. In particular, I know a big part of our customer base is in film production. How are servers, and storage solutions to a smaller extent used in film and media in general?
Yeah, we're obviously seeing a huge shift to more computing horsepower as movie production and TV production. They get more into special effects. They get more into real time LED volume. We're getting away from the traditional green screen where it's superimposed later, and we're doing it all with like LED volumes and synchronized cameras, and that's really pushing a lot of this technology forward. The big issue we have though is that you have the high end computing products that are traditionally data center server products, and you have workstation products, and they kind of want the horsepower that's somewhere in between. They want that heavy horsepower, but it still has to be quiet. It's got to be smaller. It's got to fit more of a workstation type mold. And so we're seeing a lot more requests for customers that are coming to us and asking, hey, how can we kind of mix those products together? Especially in that virtual production space. We have a lot more customers that are looking into new synchronization standards like the SMPTE 2110 workflow, which is currently best utilized on NVIDIA Bluefield cards.
Mm-hmm.
NVIDIA Bluefield cards are a data center product, not a virtual production product. So the team here has been having to come up with unique solutions to kind of meld those two worlds together to deliver the products that these virtual production teams are looking for. Um, Lots of horsepower, but quiet. And they need specialized things like video and audio synchronization and a lot of other technologies that we're working to incorporate and kind of bring all those worlds together into one product. And so you'll see a lot of that development on our Rackstation product line specifically, where we're pushing into the high end Threadripper Pro, still a workstation class CPU, but we're adding heavier power, more GPU capabilities, more high speed networking. You're seeing a bigger mix of things flowing down from the data center into those workflows, and we're working really hard to combine them all into specialized products for those industries.
Right on, right on. You've mentioned a couple times now this Bluefield and the SMPTE 2110, was it?
What's FP2110? Yeah.
Yeah. Could you expand on it? What are those? I've heard Bluefield a few times around here in the office and such, and you mentioned that it was a data center specific sort of product. What is it that makes
What
it
is it
more?
for?
Yeah, what's it for, and why is this particular to that
So
industry? I suppose.
yeah, so the Bluefield product kind of came about, as far as I understand it, and I'm far from an expert when it comes to the virtual production side of things. I know just enough, but Bluefield was originally designed to be a data center network accelerator product. NVIDIA bought Mellanox and has brought their high speed networking under the NVIDIA umbrella, specifically for HPC and AI. And Bluefield became a product that basically utilizes an onboard accelerator to do offloaded workflows away from the system host and allow for like direct communication from a system's GPU memory or VRAM directly out to the network and to another GPU's direct VRAM, right? So in terms of the SMPTE 2110 workflows, they're utilizing that onboard accelerator or that onboard processor to basically they can load a containerized operating system onto that network adapter directly and have it do a function. So the Bluefield devices are specifically for a lot of offload for the HPC world or for cybersecurity, but it's also got the ability to do the synchronized clocks for virtual production, where you need to have synchronization between all the different GPUs that are running your LED volume, the camera angles. They all have to talk on the same schedule and the same clock. And so SMPTE 2110 is a new IP based protocol that we're seeing a lot of virtual production companies move to, that basically allow them to use that synchronization much farther. It used to be limited where they had to do conversions, and this is where I get a little hazy because it's not my exact workflow, but where they would have to extend like DisplayPort or HDMI connections over a distance, and there was limitations and constraints to doing so. And SMPTE standardizes a lot of that communication on the synchronization, and allows it to be standardized through standard networking protocols. So it's a pretty big deal for the virtual production industry, and we're seeing a lot more people migrate to that. Unfortunately, Bluefield being the best product for that, we would love to see NVIDIA be able to embrace that workflow a little bit more and give us some more flexibility on those products. But nonetheless, it's still a great way to implement that. And so we're seeing a lot more of those requests for that product.
I have to say, I love how scrappy this virtual production community industry has been. They've been taking these tools that have like Unreal, right? Everybody knows Unreal Engine like powered The Mandalorian and things like that. But that's a game development software. Like it, it it never ceases to amaze me how industrious and clever and creative these people are being by using these tools that in just weird different ways. I mean, a game engine for the visuals. You're talking about scientific computing or AI, these high speed networking gear to make sure that the software is synced with the hardware, and it's super neat. I think it's very cool. I love these sort of creative solutions.
Yeah, now that's a good point. That's the other area of it that I didn't touch on is the tie-ins with Unreal using NVIDIA's RiverMax technology.
Okay.
Um, Again, not an expert. I know roughly what it is and what it does, but I unfortunately am not our virtual production expert. Um, but that's where that technology is really excelling, is especially with the tie-ins on the Unreal Engine. But when you think about it, Unreal is pushing the boundaries of what looks real and what doesn't for video games. Why not use that for film?
Since we don't do sort of these cookie cutter pre-built configurations, what should someone who wants to kind of get into this, what sort of questions should they ask themselves first, um, before
Or
starting down this path?
for virtual production or just workflow in general?
Let's say just workflow in general.
Okay. Yeah, the hardest part about designing enterprise systems is, unlike some of the other products that we offer, where we know what the workflow exactly looks like for Unreal or for any Adobe product suite type products or any of those other technologies. Um, the workflows aren't cut and dry like that.
Right.
And so a lot of what myself and the sales team spends time working with customers on is that consulting side of things. Is bring us your problem, explain what your problem is, and let us help you cultivate a solution that'll fit your needs, your
Mhm.
budget, your environment, all of that. That's where we've seen most growth. Is it's not typically about the I need a server for my data center. I already know what I want. Here, slap it in. Like there's plenty of places to go get systems like that. But if you are looking for assistance in planning, assistance in future proofing, assistance in hey, I don't really know what I need to solve my problem and accomplish my goals. That's where we can really kind of step in and help and bring the portfolio of products that we have access to into finding and developing that product. I know I've worked on a few recently, some for some virtual production, where there was very specific use cases for a large LED volume deployment, and they roughly kind of knew what they wanted, but they came in looking for a server product, and we said, "Well, where are you going to put this?" And they're like, "Oh, it's going to be right next to a sound stage." We're like, "Well, we
Maybe
probably
not.
need to look at something else for that." So we helped them kind of understand what their criteria was, and we designed some specialized products to fit exactly that need. We have other customers that are coming to us with very specific requirements around um, lidar data collection,
Mm.
or drone footage data collection, and they need to do a bunch of point clouds, and they need to be able to bring that data in from the field and process it and store it and retain it. And so a lot of that's just talking to the customer and understanding what that workflow looks like, um, and trying to help them design systems that do what they expect them to do. And there's not a canned solution for that because every customer is different. Every software suite they're using is different. For that specific customer, they're utilizing 5 different software packages, and they all have different requirements. But we need to design systems that work with all those different software packages. So there's a lot of hands-on that goes into the design around some of the enterprise products.
Nice. Oh, that's cool. It sounds like we're capable of helping even somebody who is very new to this. Who might not necessarily, like you were saying, they were going to put it next to a soundstage, and like, well, maybe that might not be the right place for that. You might want to set it someplace else, and then we can talk about, because I mean, there's everything from the actual physical racks. There's battery backup. There's power considerations. There's a lot of there's just a lot of questions and things that people may not think of, and so it's good to hear that we can help them from basically zero all the way to a fully implemented solution.
Yeah, and we also I wanted to make sure I mentioned, we do have design services available through some partnerships, so we can actually do custom chassis design, custom front panel design. Um, if you want us to just help you come up with that product, but it'd be branded your product, we can do that as well. We've done
Nice.
some pretty wild stuff there, so that's always something that we can help with.
Oh, that's cool. I know just from the ones that I've seen that have our branding on it, they are it is really well done. It's fun to see the evolution of um, the aesthetic of computing. Back in when I was a kid, it was all just taupe, beige, and rolled steel chassis and things like that. And now, you have custom screen printed front panels and all this other extra cool stuff. It's neat to see that. It's neat to see some of that kind of go into these more professional implementations as well.
Yeah, it's always exciting to go into a data center deployment, and there's just racks and racks of whatever product you worked on.
I'm curious about liquid cooling when it comes to rack mounts. I've seen some posts. I think Gigabyte tends to be the loudest with their liquid cooled solutions. Everything from like custom loops to like submerged, and that one kind of weirds me out. So yeah, I guess what are your thoughts on that in terms of because I know generally Puget Systems is not into custom loops because of the maintenance considerations and things like that. But when we're talking so much power, literally like electrical power, and then the heat that's generated from these from the components and stuff, how do we navigate that?
I'd say it, especially for Puget, in the probably the last generational product launches from a number of the different partners, um, our R&D team has made the pivot to all-in-one liquid coolers for the next generation, like AMD products, as well as some of the Intel products, and that's out of necessity. Um, we're getting to a point where we have two fundamental problems when it comes to advancing our computational technology. One is heat, thermal dissipation, and two is power. Those are the two biggest things you'll see. If you've been to the supercomputing show the last couple years, the common theme you'll see is everything is moving to liquid cooling in the data center. You're moving to two different technologies. Usually, you're seeing facility-based liquid cooling, or you're seeing immersion cooling, are the two that we're seeing. The next generation GB200 high-end AI NVIDIA products, those are completely liquid cooled from the top down. So your CPUs are liquid cooled direct to chip. Your GPUs are cooled direct to chip. Your networking is cooled. Your storage is cooled. That flows then into the back of your rack through manifolds. And then your network and power distribution is liquid cooled. I even heard that some of these racks that are pushing 1600 or 160 plus kilowatts in a 42U rack, the actual power delivery bus bars in the back of the rack are liquid cooled so that they don't melt. So when we're talking about next level computing, liquid cooling is the only way we have right now to deal with it until we see some of these next gen technologies come out where we're hitting the thermal limits of heat dissipation from the silicon itself, the substrate in the chips. So I've heard talks about diamond substrate because it has better thermal characteristics. Now we're getting into science again. That's way beyond my means. But no, I think those are going to be the biggest challenges we'll see. I kind of mentioned it before that our dual 5090 products are moving to either a dual power supply or a 240, 208, 240 volt system because we need the power to ensure that those cards are running at full capacity. That's been a challenge because I know there's some other competitors out there that are still producing them on 110, 120 volt capacity power supplies. But in our testing, we've seen that's not enough to let those products run at their full capacity. So you're going to see a lot more of that, especially in the data center. We've already partnered with another partner, Comino, for a liquid cooled rack station product that supports up to 6 GPUs, all self-contained liquid cooled. The hardest part is going to be how to deploy that type of technology in your data center if you're doing it on-prem and you're not deploying into a data center that's already built out for that, because there's a lot of facility considerations because you need to have the waste heat coolant flow through the building. You got to exit your server rack with that hot liquid. It's got to go to a condenser, a roof unit, and that's all got to be facility based. So there's a lot of considerations we'll see there, and then power. Power is the next thing. A lot of data centers are having to upgrade their power requirements, or they just have to limit what they can do. And we're seeing a lot of new data centers being built. One of the coolest stories that I've heard recently, Houston, I don't know if you even heard about this, is the nuclear reactor on the East Coast, 3 Mile Island.
Yes, Microsoft wants to start that back up.
Microsoft is in the process of starting that back up.
Oh.
Last I heard, they signed a 20-year power delivery contract. And as far as I understand it, that reactor is specifically going to be powering AI data centers on the East Coast.
That's
That's
bonkers.
the type of power that we're talking about for these next gen products.
That's
So,
crazy.
um, the power delivery that we're seeing out of like a 5090 for workstation desktop use, I don't expect to see the products go much faster than that. I think they're going to have to get more efficient,
Yeah.
um, because we're taxing the limits of what a physical workstation can do.
Hmm.
The data center is going to do what the data center is going to do. They're going to continue, you know, um, flying into outer space when it comes to power and cooling. But you're going to see much more of that, not less.
Dang, that's no. It's interesting that you mentioned the efficiency part because they did just or Nvidia just recently was talking about their professional cards, and they have one of them, the QMax. I'm not
Max two.
going, or yeah, I'm not going to appropriately have the model name out there because, but apparently it's half the power draw with like somewhere around like 90% of the performance, and it seems that there's a very steep there's a point where it the power requirement or the push of the power at least just goes that knee curve. It's not so much a knee curve as it is like there's a just a particular point where it just goes
Yeah,
skyrockets. And yeah, I think you're right. They're going to have to figure a way of balancing that better because even on the consumer side, we can't have a 1600-watt graphics card, but that just seems to be where it's headed, and that seems very strange.
yeah, and I think that's why. Um, I know the jury's still out a little bit on like if we step away from the workstation side of it, and we look at just like the pure gaming side of like the 50 series cards. They're using a lot of generative um, uh, boosts on that card to get some of the performance numbers, and there's been um, a lot of hate towards the fact that they're doing that. But I think if you step back and try to understand the bigger picture of where we're going with power, where we're going with cooling, we're going to hit a point where you know people aren't going to be building 208-volt circuits into their house just for their gaming PC or for their home desktop. So there's got to be a point where to continue pushing that technology, we're going to have to come up with other ways. Um, uh, I think they could have done a little bit better on how they portrayed that, but I definitely understand it, and I understand that there's requirements that we need to hit from power and cooling, um, and that's going to be that challenge from this product and into the next product. I think you're going to see more of those types of advanced features that um, uh, kind of skirt around just the raw horsepower of things. Like there's got to be ways to build that power without just throwing more watts at the products. So um, I think that's what we're going to continue to see on those products, and that's just my gut feeling that that's what I kind of expect.
I imagine it's going to be something similar to CPUs. We kind of hit well, heck, I mean, there was a bit of a plateau where they weren't just pushing more watts to get more performance, and now we're kind of seeing more of that again. Like we have 165-watt consumer processors and things like that. But I think it does have these sort of reach plateau. So I
Yeah,
wonder, and I also wonder how ARM plays into some of this. I don't understand enough of how that is, and the very deep level. I know it's like a whole different instruction set. It's a whole different way of doing processing. Um, but it's very low power. But it's also, it's a little
yeah,
beyond me, and so I'm just curious how some of that all plays together.
yeah. I mean, we're seeing uh, 5 to 600 watt CPUs from AMD on the data center side in the next generation. Intel has taken the split road where they're doing their performance cores and efficiency cores as separate products. So they're not melded into one CPU anymore. You're going to get the E core product or the P core product based on your workflow and your needs in the next Xeon 6 launch. So uh, we're seeing the manufacturers kind of talk about, oh, we're going to go up in wattage, and then we've seen them kind of oh, okay, that we pulled it down, we pulled it back up. There's even they are still trying to figure out as they're road mapping out the next generation products, what are they going to do with the thermal design here, right? We're pushing those limitations, and that's why you're seeing a lot more in the server products. They're direct to chip cooling, so instead of having a heat sink and fans, they've got water pipes coming out the back, and they go into your rack, and you have to have a manifold with hot and cold, and that's just the way to get the density for those next generation chips.
Wow, it's exciting times, and it's one of the coolest things about working for Puget Systems is being right on the edge of all of this really fascinating new, just new everything. Whether it's new and creative ways of using different software, new products, and advancements in computing and all this stuff. It's really really cool.
No, it's a every day is different.
Yeah. So
The technology and the world stage combined are making for very interesting times in the world of computing.
it's it's exciting. I think it's really cool. So all right, well, that brings us pretty close to. I mean, I guess that this brings us kind of to the end of things. Like I said, it's very exciting times where it's always fun to be right on the, like, really the bleeding edge, the cutting edge of things. And so, thank you, Chris, for joining us today. I think this has been actually very informative. I think I always kind of see myself as an audience surrogate. I don't know everything that's going on around here. I don't know all of the new stuff that everybody gets to touch on and things. So I appreciate you taking the time to educate not just me but our audience at home as well.
Yeah, no problem. Anytime.
Right on. And so, and as always, I like to thank the audience as well for joining us. And we'll see y'all next time. Thanks.